Okay, so we are starting a brand new unit. This unit is called 3D figures. So we are going from two-dimensional, finding the area of a figure, and now we're going to take that figure and we're going to give it a height. And we're going to go from 2D to three-dimensional, 3D solids. So take a look at what I have on the board. What are all of those pictures called? What are those called? Do y'all know? It is called a net. A net is a 2D representation of a 3D solid. So those are nets. It's what our 3D solids look like when they are flattened out, when they are unfolded. So let's go through what each of these nets are called. First of all, let's kind of compare and contrast what we see. Can you tell automatically which ones are prisms and which ones are pyramids? What do you think? All right, yep. Prisms have two bases and the pyramids have one. When you unfold a prism, you've got a base, not a prism, a pyramid. You've got a base and you've got lots of triangles. But when you unfold a prism, you have two bases and you have rectangles. So that can automatically kind of help me out and give me a clue as to which word to pick. So what's number one? Number one. Number one up here. Triangular prism. What about number two? Number two. The way you say that is pentagonal prism. No, it's not. That's a trapezoidal prism. That one's fun to say. Say trapezoidal prism. It's fun. Number two is a trapezoidal prism. Number three, the one I was looking at, pentagonal prism. Number four, what's number four called? Whatever. So this is definitely a triangular pyramid. There we go. The next one is, of course, a cylinder. Did you know that when you unfold a cylinder, you get a rectangle and two circles? Oh, it's the Triforce. Oh, okay. The next one, of course, is a rectangular prism. What's number seven called? Number seven. Square pyramid, yes. Maybe it's a rectangular pyramid. We'd have to see some tick marks to know for sure. And that last one, 6 sides, 6 rectangles, hexagonal prism. All right, in your notes, please draw this figure and label the parts. Okay, let's go over these parts. A, what is A pointing to? What is that? Well, we know it's a segment, which automatically makes it an edge. And in this case, yet it's a lateral edge. It's not a base edge, it is a lateral edge. Okay, the only other edge up here is, of course, the base edge. That is B. The base edge is also a segment. So edges are segments. That's just good to note. It's like a line. C, what is C pointing to? That's a vertex. Another, so that would be a point or a corner. People might call it a corner. So a point, a corner, a vertex. Plural of that would be vertices, of course. And what about D? D is pointing to? Now the base of a 3D solid is also one of the faces of the solid. A base is a face. Is that confusing? It's a base face. No, I'm just kidding. But a base is a face. So that's a segment, that's a segment, that's a point. This is a 2D figure. The base is a 2D, some sort of 2D figure. And then, of course, E is pointing to the lateral face. Now, in a prism, that is always a rectangle. But in other shapes, it could be a triangle or something else. So, good to know those words. Okay, we're going to do a few fun riddles, and these riddles will make sure that we know all of our vocab. Do not write these in your notes. These are your only choices up here. These shapes up here are your only choices, the pictures. I have exactly one base, and I have 3 lateral faces. What am I? If I have exactly one base, I have no choice. I have to be a pyramid. Pyramids have one base. Now, here's where it tells me what kind of pyramid it is. I have 3 lateral faces. So, you know what? In any shape, the number of lateral faces is congruent to the number of sides of the base. So if it's a triangle and the base has 3 sides, then it's going to have 1, 2, 3 lateral faces. Throwing shapes around. The answer to this one was triangular pyramid. Next one. Each of my lateral faces is a rectangle, yet my bases are not. I have only 6 vertices. The answer to this one is triangular prism. Let's dissect this. Each one of my lateral faces is a rectangle. All right, now we know it has to be a prism. My bases are not. Okay, so it's not a rectangular prism, so that one's out. I have only 6 vertices. Now, your brain wants to, when it hears 6, it wants to go hexagon. It wants to go there. But how many vertices? Remember, we're 3D now. We're not 2D anymore. How many vertices does a hexagonal prism have? How many vertices? 12. Yep. I have only 6 vertices. So that's why we needed to choose triangular. It has 3 vertices on one side and 3 vertices on the other side. So that's the winner. Next one. I have more edges than the other solids on this page. Ooh. I have more edges than the other solids on this page. Hexagonal prism. Very good. How many edges does a hexagonal prism have? How many edges? 18. Very good. It has 6 here. It has 6 here, so we're now up to 12. And then it has 6 lateral edges. So it's really 6 times 3. Remember, these are 3D, people. They are not 2D. They have 3 dimensions that you have to worry about. My base is a circle, and I have 2 heights, one that slants and one that does not. Very good. We've talked about that. No, we actually haven't talked about this one. I'm thinking of the next one. My base is a circle, and I have 2 heights, one that slants and one that does not. And we'll learn about cones on another day. If you drew my net, it would consist of 3 shapes, a rectangle and 2 circles. Very quick, guys. Cylinder. Yes, of course, we talked about that. Last one. I'm very interesting because each pair of opposite sides is parallel and congruent. Therefore, any one of my sides could be considered my base. Nice. Quick. We're not going to say cube. Yes, cube could be an answer, but in this one, we're going to do rectangular prism. Any one of those sides could be the base. So the problem is going to have to tell you. A rectangle is sometimes a square. A square is always a rectangle. All right, let's move on in our notes. So we're no longer going to talk about all the shapes anymore. We are zooming in and we are talking about prisms now. We have in architecture, lots of prisms, a lot of skyscrapers, a lot of buildings are prisms. A pencil, a lot of pencils are hexagonal prisms. This tent is a triangular prism. Write this down, please, in your notes. A prism, the definition. This is a really good definition. It has a lot of important words in it. It's a solid with a pair of congruent bases and parallel planes. Lots of important things. Let's dissect this definition. It's a solid. All right, so that's telling us right away that it's 3D. Pair. Oh, that means there's 2 of them. The bases are, there's not just 2 of them, they're congruent. And they're in parallel planes. That's a lot of math in one definition. It's 3D, there's 2 bases, they're congruent, and they're parallel. All right, so we have a rectangular prism, a triangular prism, and a pentagonal prism. Always 2 bases, always the same size, always parallel. Please don't write any of the rest of these definitions down. Please just listen. You do not need to memorize these or even look at them again. The lateral faces are, notice, they're the rectangular shaped regions because in a prism, the lateral faces have to be rectangles. So when I unfold this net, notice all the lateral faces are rectangles. They're formed by joining the vertices of the bases. So that's kind of how we draw a prism sometimes. Sometimes you draw two bases, and then you connect the vertices. When you connect the vertices, you have just drawn lateral faces. So the lateral faces are going to be that rectangle right there. The lateral edges, watch this. It's going to turn from blue to purple. It's not a big color difference, but watch. The lateral edges are the edges that connect. Did you see it? They're the edges that connect the base to the base. The common edge shared, this is fancy, the common edge shared by the adjacent lateral faces of a prism, aka the segments that join the lateral faces. Okay. The bases are, of course, the one that we have two of, they're congruent, and they're parallel. I want you to really notice, because this is what most students get wrong. A prism, or a shape in general, is not always going to be sitting on its base. No matter how I set this prism down, the triangles are the base every time, because the triangles are what there's two of. So even if I set the shape down like this, the rectangle is not the base. The triangles are the base, because the triangles are what we have two of. The rectangle is not the base, not of a triangular prism. Okay. The height is the altitude of the prism. It's the length of the lateral edge. Some of our problems, our worksheets might call a prism a right prism. I just wanted you to know what a right prism was. A right prism, of course, is like where they're perpendicular to the base, whereas an oblique prism is the Leaning Tower of Pisa, where it's leaning, okay? All of our prisms, we can assume that they are right prisms in our class. All right, take a look at this right here. What is the height of each prism? Because if you can't get the height correct, then you're not going to plug it into the formulas correctly. So let's look at the green one first. What is the height of the green prism? It's not 5. It's not 7. Very good. The height is 9. And that's hard for some students because they're not used to a height on the ground. They're not used to that. But the height is whatever value connects the base to the base. Connects the base to the base. So if you're having trouble finding the height, I want you to touch one of the bases and then travel to the other base. And that value is the height. What about on the next one, on the purple one? The height of the prism is not 8. The height of the prism is 12. I want you to touch a base and then travel to the next base. And that is your height. The height of the prism is not 8. Did I come across okay? Is that okay? That's the most important part, really. That's what students mess up on. There's 3 measurements that we are going to be calculating during this unit. LA, SA, and V. LA stands for the lateral surface area. So that would be like you're going to paint your room. Usually when you paint your room a color, you do not paint the ceiling and you do not paint the floor. So you are painting the lateral faces of your room. That's a time in the real world where you would want lateral surface area. Another time is the good old soup can label thing. I want to put a label on a soup can. Well, I'm not going to put the label on the top or the bottom, so I would want the lateral surface area of my can to see how big that label needs to be. SA, when you see SA written somewhere, that means total surface area. So if you're wrapping a present for a birthday party, you're going to cover the whole present, hopefully, unless you run out of paper. So that's the total surface area. And then, of course, volume, the number of cubic units in a solid. Usually we think of liquid when we think of volume. We think of filling something up, the inside, when we think of volume. Alrighty, let's try out our formulas. All of these are on your formula chart, so you don't need to worry about memorizing any of these. The first formula is for the lateral surface area. LA equals PH. Now, although these formulas are on your formula chart, you have to know what the variables mean. So P means the perimeter of the base, and lowercase h means the height of the prism. All right, so the first thing, a lot of our quizzes and even a little bit on the test, it's going to lead you to find each variable before it just throws you out there and says, find the surface area. It's going to kind of lead you. So first it's going to ask you for the perimeter, and you're going to find the perimeter of the base, only of the base. 3 plus 4 plus 5. So the perimeter is 12 centimeters. The height of this prism is, of course, well, look at that. It's also 12 centimeters. And the lateral surface area, P times H, 12 times 12, 144 centimeters squared. So that's how you find the lateral surface area of a prism. Total surface area, here's the formula. PH plus 2B. Sure, you could just find the area of each one of the faces and add them all up, but that's what formulas are for. Formulas are just to be efficient. What is the quickest way I could do this? And that's where formulas were born. So, notice, does this look familiar? PH plus 2B. Well, PH, wait a minute, that was already the lateral surface area. So you've already found it. You don't have to find it again. I kept the same shape. You do not have to re-find the lateral surface area. The base. Very good, the area of the base. The base is a triangle. So we're going to do base times height divided by 2. 3 times 4 divided by 2. The area of the base is 6 centimeters squared. And now we're going to go to our formula, surface area. PH plus 2B. PH plus 2B. 156 centimeters squared. Last but not least is volume. Once again, don't have to memorize the formula, but you have to know what those letters mean. All right, so volume is capital B times H. It's the base area times the height of the prism. We've already found the area of the base. It is still 6. We already know the height of our prism. It is still 12. So base times height. What is the volume? 72 centimeters cubed. That's the first time we've ever cubed something in class. 72 centimeters cubed. All right, let's try one more example. Those are your formulas on your formula chart. Let's try one more example. Let's go through it quickly. What is the perimeter of that figure? Not the figure, I'm sorry. Capital P stands for perimeter of the base. So I want the perimeter of this triangle. So I'm adding 12 and 20. And what's that missing side? How do we find that? Pythagorean theorem. Good. So the perimeter, I'm adding 16 plus 12 plus 20. The perimeter is 48. All right, what about the height? That's easy. The height is 10. The lateral surface area. Okay, that formula is PH. Well, that's easy. 48 times 10. All right, capital B stands for area of the base. It's the area of the base. So we have to go to the base, and we have to find the area of it. 12 times 16 divided by 2. 96. The surface area, the formula says PH plus 2B. Well, we already know what pH is. It's 480 plus 2 times 96. pH plus 2B. And finally, the volume. Base times height. The area of the base times the height. So the area of the base has already been found, 96. The height is 10. Woohoo! Easy multiplying here. 960 centimeters cubed. An aquarium owner has 200,000 gallons of water. That's good because they own an aquarium. What percentage of the fish tank can she fill? 1 cubic foot equals 7.48 gallons. All right, let's work this problem. First of all, we need to find the volume. How do you find the volume of a rectangular prism? Technically, the formula says base times height, but the base is just a rectangle. The base is length times width. So really, the volume is length times width times height. That's not bad. Let's find the volume of this aquarium. 55 times 10 times 115. 63,250. Now that is cubic feet. We don't know how much cubic feet of water we have. We know how many gallons of water we have. So we're going to need to take our answer and multiply by 7.48. So I have 473,110 gallons that I could fill. How do I know what percentage I'm going to fill when I pour 200,000 gallons in there? What do? Well, you take the number of gallons, 200,000, and you divide it by how much it holds, 473,110. So you take the number of gallons over how much it holds. You're going to get 0.4227, and then to make it a percentage, you move the decimal place over twice. So it'd be 42.27% or 42.3% or something like that. Last problem, guys. The surface area of a cube is 150. What is the length of the base edge? The surface area of a cube is 150. What is the length of a base edge? Well, what we know about a cube is that all of the edges are the same, right? All the edges are the same. So when we find one of them, we've found all of them. How do you find the surface area of a cube? You could just find the area of this. And then how many faces does a cube have? No, that's volume, Pavin. That's volume. How many faces does a cube have? Okay. So I'm not using the formula on my formula chart. Are y'all okay with that? I could have used it, but I would have came up with the same thing, and it would have taken me a little bit longer. How do I solve for x here? How do I solve for x? Divide by 6. You know Miss Hannon made the answer nice. You know it wasn't going to be a decimal. X squared is 25. X equals 5. I didn't give you much time to work that out without me. But now you could work backwards on a future one. Now you know how to do it. Make sure you're reading, and we're using surface area and not the lateral area or the volume or something like that. All right? All right, your homework tonight, we're not going to do that. Your homework is called Prisms. Make sure you try it and bring your questions to class tomorrow.